All right, guys. So now you know how to estimate to figure out what the answer is going to be close to when we're multiplying decimals. Now it's time to figure out exactly how to multiply decimals. And if you know how to multiply whole numbers, well, then it's the same but different. In fact, it is so very much the same. It's really more like it's the same but a little bit more. So let me explain it to you. Multiplying decimals is a 3-step process. We're going to do steps 1 and 2 first to make sure you understand those steps. Then I'll introduce step 3. Step 1 is pretty simple. It's called playing pretend, and I'll explain what that means in a minute. And then once you play pretend, which we all like to play pretend, the next thing you're going to do is solve. All right, so let me explain to you what I mean by play pretend. Play pretend basically means that we can see that these are decimal numbers and they have decimal points. But for the sake of solving the problem, we're going to pretend that the decimal point isn't there. It literally disappears. Not that the decimal universe disappears, but the actual decimal point. So instead of 6 and 7/10, it would just be the digit 6 and 7, so it would be 67. And instead of 8/10, it would simply be just 0.8, which is really just the number 8. So guys, this is all it takes to do step 1. You're going to pretend that the decimal points aren't there and create a problem with only whole numbers. Well, here's the great thing. You totally know how to solve whole number multiplication problems. This is a 2x1. So you're just going to go ahead and set up the problem. And 8 times 7 is 56. And you're going to go ahead and solve just like you normally would. 8 times 6 is 48, plus 5 is 53. So steps 1 and 2, playing pretend and solving, what they're going to give you are the digits that are in your answer. All right. It's not your final answer. That's going to happen when we add step 3. But this is just going to give you the digits that are in your answer. We'll get to the rest in a minute. Let me show you again how step 1 and step 2 work. To play pretend, I even like to draw a little thought bubble. This 14 and 5/10 would really be 145. Just remove that decimal point. And the 9 is already a whole number. It just stays a 9. So step 2 would be simply to use the standard algorithm or whatever strategy you like for multiplication to solve it. 9 times 5 is 45. Carry the 4. 9 times 4 is 36. Plus 4 is 40. Carry the 4 again. 9 times 1 is 9, plus 4 is 13. Now, I'm not going to throw in a comma, even though that would be our next step, because this is not our final answer. This is simply telling you what digits will be in our final answer. Again, step 3 will reveal the final answer. Let me show you another one. And this is what's really nice. This problem might look really scary, but it's not. Because when I play pretend, 0 and 6/10 is really just 6. And 0 and 7/10, it's really just 7. So the solving step, well, I don't even need to set it up. This is a multiplication fact. 6 times 7 is simply 42. Now, again, this is not the final answer, but I know my final answer will have the digits 4 and then the digit 2 in that order, but there'll be something more added to it. That's step 3. All right, let me just show you one more kind of tougher one, because when I play pretend with this problem, I get 53 times 29. And the reason this is a little bit harder is that when I go to solve it, this is a 2x2 digit. So I'm going to go ahead and show you split standard for this one. So 52 times 9 over here, and over here 52 times 2. And see, 9 times 2 is 18. 9 times 5 is 45, plus 1 is 46. So I know part of my answer is 468. 2 times 2 is 4. 2 times 5 is 10. Because that 2 is really worth 20, I'm going to take that 0 and annex it there. And then I'm going to combine my 2 parts into my final answer for these 2 steps. That is 10, carry the 1, 15, carry the 1, and 2. Now, again, this is not my final answer. These are the digits that will be in my answer. We'll get to step 3 in a minute. All right, again, playing pretend and solving, we know that this would be 9 times 32. The reason I wanted to show you this one is if you tried to solve it like this, that's not how we set up multiplication problems. Unlike addition and subtraction, which are part of COAS, where we line them up, Multiplication is different. We always want the number with more digits on top. That is just how we're used to solving them, and it's okay to flip them around. 9 times 2 is 18, carry the 1. 9 times 3 is 27, plus 1 is 28. So this is what you get at the ends of step 1 and 2. So it's now time for you to practice these. Again, all I want you to do is pause the video. You're going to do steps 1 and 2 only for these 3 questions. Play pretend, actually set up that imaginary thing for each one, and then solve it. Just do them on scrap paper. When you're done with all 3 of them and you get the answer part like this, where it just gives you the digits we're looking for, you can go ahead and hit play. And on the next part of the video, I'll go over those answers. All right, for this one, your play pretend should have been 45 times 3, not 03, because 03 just means 3. And when you solved it, you should have set up the problem. 5 times 3 is 15, carry the 1. 3 times 4 is 12, plus 1 is 13. So you should have ended up with a 1, a 3, and a 5 like that. Let's look at the next one. This play pretend would have been 163 times 5. That's step 1. When I go to solve it, I'm simply going to set this up. 5 times 3 is 15. And 5 times 6 is 30, plus 1 is 31. Carry the 3. 5 times 1 is 5, plus 3 is 8. You should have ended up with 815 as this part of your answer. And last but not least, this one's a little bit more challenging because this, when we play pretend, gives us 74 times 13. And this is a 2-digit by 2-digit. For this one, I'll model it in standard algorithm, starting with the 3. 3 times 4 is 12, carry the 1. 3 times 7 is 21, plus 1 is 22. That's the first part of my answer. So I'm going to play X's and O's. And I'm going to move to the tens place. 1 times 4 is 4, and 1 times 7 is 7. This is the other part of my answer. And to finish up, I need to combine them. So you would be correct if you got 962 here. So I'm going to go ahead and stop this video because I know it's long. It'll give you a stretch break. And in the very next video, which you're going to go ahead and watch, I'm going to go over what's the final step, because this isn't whole number multiplication. This is decimal multiplication. So our answer is going to need a decimal point. It's all just a matter of how to know where to put that decimal point.